Welcome back to Math 151. At the end of the last video, I gave you 3 examples of derivatives that must be computed using logarithmic differentiation. Here's the first one, 1 plus x raised to the 2x. Since we already know we have to use logarithmic differentiation, then we're going to start by setting f equal to the thing we want to differentiate. And then, as always, step 1 is going to be to take the natural log. Notice here we just have to use that single log rule which pulls the exponent down. So we take natural log, something with an exponent, then the exponent comes down, and we get natural log of the base. Now in step 2, when we differentiate, we're going to have to use the product rule. We're also using the chain rule in this last step, but the derivative of 1 plus x is just 1. Finally, step 3, we multiply. And that's the end of the problem. Here we have our answer. Good habit to box it. Our second example was this one. We have a product, x squared plus 1, and the other factor in the product is that kind of exponential thing, x to the sine x, where both the base and the exponent are changing. And that's why we have to use logarithmic differentiation. We set f to be that thing that we want to differentiate. And in step 1, now when we use our log rules, there's going to be 2 steps. First, we're going to see this as a product. That's the top level operation here, is product. You compute x squared plus 1, you compute the other thing, x to the sine x, and you take their product. So log rule says those turn into a sum. And now, not the top level, but the next to top level is where the exponentiation happens. So that second term, ln x to the sine x, that's going to be reduced with another log rule. So that's the end of step 1. In step 2, we're going to differentiate, carefully using chain and product rules. The first term's just a chain rule thing. The second term, we have to use the product rule. Now in step 3, we just multiply. That's our answer. Here's our final example. Now we have one of those exponential things, ln x, that's the base which is changing, raised to the x, also changing, but we divide it by cosine x. So the top level operation here is quotient. We have to use logarithmic differentiation because the numerator is one of those exponential things with changing exponent and changing base. So we set f to be the thing we want to differentiate. Just like in the last example, taking the log here is going to be a 2-step process. First, at the top level, this is a quotient. So we have ln of the numerator. It's a little weird because there's an ln on the outside and the inside. That's why it's important to keep everything in mind. We're doing ln of numerator minus ln of denominator. And now, the first term can be further simplified. So the exponent, x, comes out. And then we get ln of the base. So ln of x. ln of x. We're composing ln with itself. And the other term's just along for the ride. Now in step 2, we're going to have to be extremely careful when we differentiate this first term. That's what makes this problem harder than the other 2 examples, or really than any of the other examples we did so far. We have a product and we have this composition of ln with itself. So we have to be very clear-minded about what we're doing. First, at the top level, we're using the product rule. That means leave the ln thing alone and differentiate x. 1 times whatever that is. Now, leave the x alone and differentiate this ln thing. First now, I don't see ln. I see ln of something. ln of something means 1 over whatever's inside, happens to be ln x here, and, says the chain rule, multiply by the derivative of what's inside, by the derivative of this inside ln x. That's 1 over x. And finally, we have to take the derivative of this last term, ln cosine x. So we have minus, and then in the bottom we have cosine x, and in the top we have minus sine x. So here it's worth noticing a little bit of cancellation. This x and this x cancel out, and this minus combine to make a single plus. So now in step 3, when we multiply, we have ln x, and we have 1 over ln x. And then this last term here is actually plus sine over cosine, which you can leave as sine over cosine, or you can write as tangent if you want to. Doesn't matter. Finally, we multiply by f. So here we chose to do a little bit of simplification. It's really just the most obvious kinds, and you don't even have to. You could have copied exactly what you had in step 2, written big parentheses around it, and then multiplied by f of x. But it's really easy to forget about some of these things. For instance, when you're differentiating here to get this second term, x times 1 over ln x times 1 over x, it's easy to forget about the 1 over x. Or, in the last term, it's easy to get confused about the minuses. So, really, this is a much harder problem than E or F, but only because you have to be a lot more careful. That's the end of our videos about logarithmic differentiation.